Now, product rule's brother, quotient rule. Well, if product rule was when you've got two terms that are multiplying together that you can't expand or simplify, then quotient rule is going to be when you've got two terms dividing each other and it's not simplifiable, such as the one on the left. Now, the reason that's the case is you can never split up the denominator. So the denominator is always going to be 1 minus 3x. So there's no way to actually simplify that. If the 5x was on the bottom and the 1 minus 3x on the top, it would be a different story because you can break it up. But you can never split up two terms that are on a denominator. It remains as a whole term. And that's really important. So in this case, that one on the left is not simplifiable. There's nothing in common that you can cancel out. Nothing. So we've got two terms that are dividing by each other that are not simplifiable. That means we've got a quotient rule. So what we want to do is we want to call our two non-dividable terms. The top one we'll call u. The bottom one we'll call v. Very similar to what we did in product rule. Now here's our quotient rule formula. Y dash equals vu dash minus uv dash over v squared. You'll probably notice a bit of a similarity in the VU dashes and UV dashes from product rule, but on the next slide I'll actually go through and explain the difference between them, or actually more than that, a good way to remember the two formulas. But for now, let's just go with that formula, VU dash minus UV dash over V squared. As we did with product rule, always chopping board it. U, in this case, is 5x. U dash will therefore be 5. V is going to be 1 minus 3x. V dash will be minus 3. Okay, we're now ready to sub it all into our formula. Again, sub them all into their own individual brackets. Okay, so let's write out that formula again. Say it out loud. VU dash minus UV dash over V squared. Now we sub in each of those in their own brackets so that we don't get any expansion errors wrong. We sub them through like that, and now we can multiply it through where need be. So we expand the 5 through the 1 minus 3x, and we'll times the minus 5x by minus 3. So it gives us, working that through one step at a time, 5 into 1 is 5, into minus 3x is minus 15x. So that's that first part. Then we've got minus times 5x times minus 3, which if we multiply them all together gives us plus 15x. And that's all over 1 minus 3x squared, because it's v squared. And just leave it as such, you don't have to expand that. Okay, now we tidy up that numerator, we tidy up the top, the minus 15x adds the 15x, and you're left with 5 over 1 minus 3x all squared. Perfect, leave it in that form, done and dusted. As I promised, here's a way to remember the formulas. There's your product rule, there's your quotient rule. You'll notice that they're very similar. You've got your VU dash and your UV dash in both of them. So the only difference though is that product is plus, quotient is minus. So you've got VU dash plus UV dash, whereas quotient you've got VU dash minus UV dash. And you've then got over V squared. And that's the only difference between the two. So you should have a go now, looking down and just running out your two formulas. VU dash plus UV dash, and quotient is VU dash minus UV dash over V squared. There are your two formulas. Okay, let's get back to quotient. Okay, example 1, quotient rule. Differentiate f of x equals x to the 4 minus 2x over 1 minus x. Now first thing we got to look for is it a quotient rule? Or can we just simplify it, in which case we won't need quotient rule? Of course you need to recall what we just went over, that you can never ever split up the denominator. So you see, can the whole denominator be divided by the whole numerator? If it can't, which in this case it can't, then it means you've got a non-quotient non-combinable, non-simplifiable two terms that won't go into each other that are dividing by each other. Hence, we have a quotient rule. So when you've got two terms that won't simplify by each other, straight away you can jump into quotient rule. Okay, chopping board. U is x to the 4 minus 2x is the top term. V is 1 minus x, the bottom term, the denominator. So u dash in this case will be 4x cubed minus 2, and v dash will be just minus 1. Now we write out our formula, of course. Every time you write out a formula, vu dash minus uv dash over v squared is our quotient rule formula. Sub it all in. Now you need to sub them in as their whole things. Don't try and skip steps here. It's really important that you sub them in their brackets and expand it through in this future steps. Don't skip steps here because you will make mistakes. So we sub in our v, our u dash, minus our u, v dash. Notice how they're all in individual brackets, over our v squared. In the next step, we can now go about expanding it through. So we expand the 1 times the 4x cubed, the 1 times the minus 2. We know that method. And what we land up getting there is 4x cubed minus 2 minus 4x to the 4 plus 2x. That's our first part. And now what we do there is we take that minus and times it by the minus 1 at the end to get plus 1. And then we'll expand that through in the next step. Okay. So it seems like there's not much happening there, but I'd rather not skip steps and write too much than skip steps and get it wrong. So all I've done in that step is just expanded the plus 1 through. So we've now just got rid of that bracket. So we've got all our loose terms there. We group our like terms. So our minus 4x to the 4 and our plus x to the 4. They'll simplify. Our 2x, our minus 2x, they'll simplify. And what we're left with is minus 3x to the 4 plus 4x cubed minus 2. All over 1 minus x all squared. And because that won't simplify any further, that is our final answer. And that is our quotient rule done. I want us to do one more slightly harder quotient rule example. And then we can push on. So I want us to differentiate f of x equals x over the square root of 2x minus 1. Now, if I know you, that should be something that is intimidating you there. That's definitely intimidator, and it is a hard question because there is that root and there's other functions, but most importantly, we're going to work it one step at a time. First things first, let's identify what type of differentiation we're going to use. We look at it and we see two x functions dividing by each other, and they are not simplifiable. You can see off the cuff those aren't going to go into one another. We can't split the bottom up anyway. It's just not going to happen. So we know we've got a quotient rule. What do we do when we know we've got a quotient rule? Well, we do our chopping board. U equals x, easy. So u dash is 1. Now our v is root of 2x minus 1. And I just want to rewrite that as 2x minus 1 to the half. Because as you've learned with all types of differentiation, you always convert into index form. And if you're not sure of that, look in the bar on the right there. Our second point, always convert into index form. That's how we differentiate. And once we're there, it's easy to get our derivative. Because you should notice that that is a chain rule. Okay, because it's a bracket to a power. So, in order to chain rule that, we bring down the power, minus 1 from the power, and then times by the derivative of the bracket. So, to tidy that up in the final step, the half times is by the 2, which cancels out to give 1. So we're left with 2x minus 1 to the negative half. And it's negative half because the half minus 1 from the power to become negative half. So that's our v dash. There are our ingredients. They're not pretty, they're a bit ugly and cumbersome, but let's just sub them in one step at a time. into our formula, which we always got to write. Remember, it helps us remember the formula if we do it each time. It's much easier to sub into as well if we have our formula right there. So we sub each of those components into our formula. And we do that carefully, very carefully. And I've especially taken that and put it there to say no skipping steps. Because this is, if we've got the harder the numbers and the uglier the numbers we use, the more likely are to make mistakes if you skip steps. So let's sub that in. We've got our v u dash minus u v dash. Again, each of them in their own individual brackets. All over v squared. Okay. Next step, we tidy it up a little bit. So the 1 times by the 2x minus 1 to the half, so that goes. Then we times through where we can. And all that'll happen is we just tidy up the brackets pretty much. Nothing really changes. But you still want to be subbing it in your brackets in your initial one because you want that to be your habit so that you don't make mistakes. The one thing that does change is the v squared. We had v was root of 2x minus 1. Square that, the root and the square cancel each other. So the bottom is just 2x minus 1, which works well. Okay. Now, as with most product and quotients, we always need to remember to take out the HCF. And this is, as I've mentioned a few times, probably the hardest part. And this is no exception. In fact, this is even slightly harder because you look at it and you know that the chain in some form, the 2x minus 1 to the half part, is in some form going to be your highest common factor. But do you take out the 2x minus 1 to the half? Or do you take out the 2x minus 1 to the minus half? Which is the highest common factor? It seems a bit confusing. So here's a hint that you can just store right in the back of your mind. When it comes up, you'll pull that out from the depths of your memory. Always, when you've got a situation like this, what you want to do is you want to take out the negative index as the HCF. So take out the negative half, and you'll see why in a sec. Just a nice little hint for future. And so we'll do just that. We'll take the 2x minus 1 to the negative half out as our common factor. Now what we've got to do is we've got to work out what do we need to times by that 2x minus 1 to the negative half to get that, our 2x minus 1 to the half. Well, we know from index laws that when we times in two like terms, their indices add. And when we divide in them, their indices minus. But in this case, we're looking to find something. We need to add to negative a half to get a half. So what we do is we times it by 2x minus 1 to the 1. Okay, so if you look at it now that it's written down there, so it seems quite confusing when I say it, but if you look at it written down there, 2x minus 1 to the negative half times by 2x minus 1 to the 1, what will happen when you times those two together is you add their indices, so minus a half plus 1 gives you a half, which is what we were trying to do. So you almost have to work backwards on that one. Think to yourself, how do I get to a half from a minus a half in terms of indices? Well, I've got to add 1. So we times it by 2x minus 1 to the 1. And hopefully that makes sense. I know it's a little bit tricky, a little bit confusing. And then for the other term, well, it's quite easy. For that term there, it's quite easy because all we have to times by is minus x. Okay, in our next step, we're just going to tidy up that bracket. Because it's to the 1, it's just 2x minus 1. And that minus is by x. So it's just left with x minus 1 in the brackets. Okay, now what we do is we realize, well, we've got that 2x minus 1 that is common on both the top and bottom. And the two top terms are times in together. So there is technically a common term between them that we can cancel out. And that is the 2x minus 1. So what we've got to do is when we divide in two powers, our index laws say we minus indices. So we do a minus a half minus 1, which leaves us with minus 1 1/2 or minus 3 2 outside of x minus 1. Again, it's another tricky step, and that's why I said this is a harder example. Just to repeat, we are simplifying the 2x minus 1 to the negative half and the 2x minus 1 to the 1. And you can do that because they're the same bases. What you can do is you can just minus their indices. Okay, that's there up to there. Now, let's push it even further, and I always like to add this. I would be happy with that as an answer, but sometimes I ask you, express it without negative or fractional indices, something we've done in previous lessons. And so, the way to do that is, remember, you take the term with the negative index. In order to get rid of the negative index, you take that whole term down to the bottom and get rid of the negative. So the x minus 1 stays on the top, but the 2x minus 1 to the 3 on 2 goes down, and we get rid of that negative from the negative 3 on 2. Now we need to get, so that's the negative indice gone. Now we need to turn it into a fractional indice. From a fractional indice, sorry. And remember how the fractional indices work? Well, the roots are beneath the ground, so the roots are on the bottom. So the 2, which is the denominator of the indice, is the bottom, which means it becomes the root. So it's the square root of 2x minus 1 all cubed. If that last bit didn't make sense, then go review the lesson on negative and fractional indices. However, if that does make sense, then you are doing really, really well. I always like to end on these harder ones, because if you're getting these, you're on top of it. If you're not, it's almost worth just going back and rewatching it, rewatching the explanation now that you're sort of familiar with the ideas. It is a very tricky one. There's ugly numbers. It's difficult. But try go one step at a time, and you should be able to get there.